In this video, we're going to take this region here and we're going to rotate it about the y-axis, and then we're going to find the volume of the resulted solid using something called the shell method. So let's go ahead and graph this region. So this is our y-axis. This will be our x-axis. So x and y. And so y equals 8x by itself looks like this. Y equals 24 is simply a horizontal line, looks like this. And x equals 0 is a vertical line, looks something like this. So putting all this together, our graph should look roughly something like this. Here is 8x, here is 24, and here is x equals 0. And we're rotating this about the y-axis. Okay, in the shell method, our rectangles are always parallel to the axis of revolution. So when we draw our rectangle, it should look like this. Right? It's not, if it was like this, we would say it's perpendicular, but that would be the disk method. So now we can identify the important things, namely h and p. So because we have a vertical rectangle, we have functions of x. So h of x is the length or the height of the rectangle. And p of x is the distance from the axis to the skinny part of the rectangle. So this would be p of x. I drew it down here, but I could have just as easily drawn it up here. So in this case, p of x is simply going to be equal to x. H of x is a little bit more work. Let's think about this. This distance here is 8x. That's the height. This height here is fixed. It's always 24. So h of x is 24 minus 8x. So 24 minus 8x. The formula for the volume using the shell method always has a 2 pi. And we go from, let's see, from 0 to, well, I guess we need to figure out what this x value is. In order to do that, we have to think about when is 8x equal to 24. That's where they intersect. That means that x is equal to 3. So this is 3. And that should make sense. If you plug in 3 here, you get 8 times 3, which is 24, which is the height here. So that's the only way that you're going to get 24, is with 3. So we're integrating from 0 to 3. And it's p times h. So it's x times 24 minus 8x. And then we have our dx. Good stuff. All right, let's go ahead and keep going. So this is 2 pi, definite integral, from 0 to 3. Distributing the x, that's going to give us 24x minus, and then x times 8x is 8x squared. And don't forget the parentheses and the dx. Finally, we have everything to a power, so we're in a position to integrate. So this is 2 pi. I'll put a bracket here and leave it on the outside. There's a 1 here, so we will get 24x squared over 2, which is really just 12x squared. Okay, so this is 12x squared, because it's 24x squared over 2, minus 8x cubed over 3, using the power rule again, and we're going from 0 to 3. So this is equal to 2 pi. Plugging in the 3 first, we get 12 times 3 squared minus 8 times 3 cubed over 3. Putting a 3 in for all of the x's. And then minus. Now when you plug the zeros in, it's really nice because they all go away. So you just get 0. It's really nice. So this is equal to 2 pi. This will be 12 times 9. Minus, this cancels with one of these, so you're left with 8 times 9, so minus 72. Right, because that's 8 times 9. All right, this is 2 pi. 12 times 9. So let's see, 9 times 10 is 90, 9 times 2 is 18. Those add to 108 minus 72. And 108 minus 72 is going to give us 36. So this is 2 pi times 36. This will be 72 pi. And that should be the volume of the solid of revolution. That's it.